Welcome to the Haes Technologies online video for our Esprit A range of addressable fire alarm panels, part 1. In this video, we'll be looking at the product overview, connectivity details, expansion peripherals, networking options, and programming features for these panels. The range comprises the Esprit A1001 1 to 2 loop panel and the Esprit A1002, which is a 1 to 4 loop panel. Details for the Esprit A1001 panel. It's a 1 to 2 loop panel. It comes in two versions, Apollo and Argus. The Apollo version supports up to 126 or 252 standard Apollo devices, or if the core protocol option is selected, it can handle up to 240 to 480 devices. The Argus version copes with 240 devices for a one-loop panel and 480 for a two-loop panel. Each panel has 18 zone LEDs, and each loop is supplied by 500 milliamps. There's a 35 watt, 1.2 amp power supply unit. The panel includes two auxiliary relays, one for fire and one for fault. It has a 400 milliamp 24 volt auxiliary output suitable for running our range of repeaters or other Haes equipment. It's not suitable for door mags or magnetic holdbacks. Each panel has two 500 milliamp rated electronically protected sounder circuits in case you want to mix conventional sounders and loop sounders. There's a USB port for PC configuration and room for two 7 amp hour batteries. It's key or code operated. The dimensions for the 1 to 2 loop panel are 350 millimeters wide, 300 millimeters high, and an overall depth of 85 millimeters. And with the door shut, the overall dimensions rise to 363 millimeters wide and 310 millimeters high. Details for the Esprit A1002. This is a 1 to 4 loop panel in a slightly larger enclosure. Again, it comes in two versions, one for Apollo and one for Argus. The Apollo version supports up to 126 for a one loop panel, all the way up to 504 standard Apollo devices. Or if the core protocol option is selected, that rises to 240 for a one loop panel, up to 960 devices for a four loop panel. The Argus version supports 240 for a single loop, up to 960 devices for the four loop panel. It's a 36 zone LEDs on the front. Again, each loop is capable of driving up to 500 milliamps. The power supply is rated at 100 watts at 3.4 amps, suitable for the larger batteries. Again, it comes with two auxiliary relays, one fire and one fault, a 400 milliamp 24 volt auxiliary supply output, again for running our repeaters and other equipment. Just to point out, it's not suitable for door mags. There are two half amp rated electronically protected sounder circuits, same as a smaller panel, a USB port for PC configuration, room for two 17/18 amp hour batteries, and again it's key or code operated. The backbox dimensions for the larger panel are 450 millimeters wide by 385 millimeters high and 105 millimeters overall depth. Each panel supplied with plenty of knockouts along the top edge. The following diagram shows you the connection details for the panel. On the left is the PSU card where the sounder circuits 1 and 2 are located, plus the PSU inputs and relays and battery connections. To the right is the loop card, again conventionally wired loop Loop A pos and neg terminals are your outgoing pair, and your loop B pos and neg are your incoming set. And then it's just a conventional loop of wiring running around to each device and back to the panel. Connectivity details. Mains input connectivity. The AC wiring should be routed to the upper left-hand side of the enclosure where the power supply is mounted. This reduces the amount of cable needed for the incoming mains to reach the power supply unit. The 2 amp version has an internal fuse rated on the 1 to 2 loop panel. The 1 to 4 loop has a 3 amp internal fuse. Each power supply unit is capable of taking up to 230 volts, plus 10% or minus 10% tolerance at 50 hertz. The small unit again comes with a 35 watt power supply, and the larger unit comes with 100 watt power supply units. Battery and auxiliary supply details. The panel requires two 12 volt 3.2 amp hour batteries as a minimum requirement. Obviously they'll be very small. As a standard size, the 1 to 2 loop panel will take two 7 amp hour batteries, and the 1 to 4 loop panel will take two 17/18 amp hour batteries. Each panel again has a 24 volts DC 400 milliamp output, suitable for our repeaters or internal peripherals only. On the right hand side there shows you the batteries need to be wired in series with the little connector link supplied. Relay information. There are two relays on the panel, both rated at 30 volts DC at 3 amps. Relay 1 is designated as your common fault relay, and relay 2 is the common fire relay, both clean contacts, fault free. The two onboard sounder circuits, each rated at half an amp or 500 milliamps, both electronically short circuit protected, so they don't require fuses on board. The circuits will clear when the fault clears on the panel, and the underlying monitoring device is a standard 6K8 resistor. Networking options. The TPC A05 network card installation. The network cards must be fitted to each panel on the network. The network card is inserted above the comms A socket on the PSU card. So you unplug the ribbon cable, you mount your network card above the ribbon cable socket, fix the new card with the 4 nylon standoffs provided, pop into place, and then reconnect your ribbon cable. Again, it must be stressed that the power must be off before you do this. And then the network cards themselves need to be addressed. The master panel needs to be set as address 0, so that will be all 4 address switches off on the network card. And then each of your slave panels will be addressed from 1 to 7. And again, if you're adding repeaters, they'll be addressed from 1 to 8. Just to remind you, the network card must be secured with all the plastic standoffs supplied. Network wiring. The panel stroke repeaters can be wired as a fault tolerant network, utilizing two core cables running all around the site. So you'll be going from the master panel out of the comms A into your first slave into comms B, and out of the slave comms A to maybe a repeater next into comms B. So it's A to B, A to B, A to B, all the way through your slave and repeater panels, and then a 2 core back again. So from your last panel, it'll come out of the A all the way back to the B channel on the main panel, and that has to be via separate 2 core cables. You can also wire it as a legacy mode or radial connection, which is standard networking. In this case, again, you can still have up to 8 panels and 8 repeaters in total on your network. But on a 2 core connection, you'll be going from the comms A in your master panel to the comms A of your next panel to the comms A of the next repeater, the comms A of the next slave, all the way through to the end. But on the first and last inputs, you'll be fitting a 120 ohm resistor, which is your termination resistor. A little note on that, if you do fit any repeaters, they will require 24 volts. That can be derived from the main panel via a 2 core or from the nearest slave panel, or you can also use a remote charger mounted next to your repeaters. Programming features. Each panel has a common graphical LCD user interface and software, a common menu structure for day-to-day operation of the panels and programming, user-friendly Windows-based configuration software. Cause and effect features are programmed only via the configuration software. The programs can't be done from the front of the panel on these. Each input can have latching and non-latching out options. Delays can be programmed to output groups. There's a total of 64 cause and effect groups, and all outputs can be programmed to de-energize on a silence or a reset command. The panels also have false alarm management modes. They have the dependency modes. They can support dependencies A, B, or C. That's displayed, non-displayed, and double knock. The feature can be used to help verify if an activated condition from a device is to be considered a genuine alarm before the fire alarm condition is displayed on the panel and the outputs go. The other way of reducing false alarms is to use investigation delays to outputs, where you could just put a full-on 2, 3, 4 minute delay on the outputs before they operate after a fire alarm condition. Moving on to part 2, which is menu options and installation information. In this section, we'll be looking at level 1 options, level 2 menu options, level 3 menu options, device information, and test mode options. In level 1, considered to be the general user level, the functions that can be performed in level 1 are mute the internal buzzer, view active faults, or change from general user to authorized user, either using the key switch on the front or by entering the 4-digit code. So in level 2, which is classed as authorized user, your default code is 1111. That can be changed. And the functions that can be performed at access level 2 are resound the alarms, silence the alarms, reset the system, mute the internal buzzer, access the user report and engineering menus, or access the config menu, which is level 3. So you would need your level 3 code to get into those. In level 2, so the first option within level 2 is your user menu. And within this, you can disable, enable devices, zones, sounders, relays, and loops. You can test all zones, selected zones, with or without sounders. There's an option for delay, which allows the end user to turn on or off any pre-programmed delays. You've got the scan option, which you can use to scan for new devices without updating the learn function. Just lets you know if anything's been added that shouldn't be there. Time and date option, set the time and date and daylight saving modes. Lamp test for testing the panel LEDs. Contrast for setting the LCD contrast and backlight options. And the buzzer option for adjusting its volume. The next menu in level 2 is the report menu. With here you can report events, number of alarms, number of faults, disablements and others. You've got the status option for checking the status of loops, devices, PSU cards and batteries. Let's look at the health and voltages. Versions allows you to look at the PCB versions on the PCBs themselves in case we need to offer an update. History allows you to look through the historical events by time and date of each activation. And a counter, which just literally counts up the outputs by time period. So how many alarms, how many faults, how many button pushes within a certain period. The next menu is the engineer's menu. Within this, you have an option for outputs. This allows the engineer to test loop device outputs. So you can turn on LEDs on devices, you can turn on the relays on an input output, or you can activate a sounder or any other kind of output device. And then error seek. This is a diagnostics mode for helping to seek errors on selected loops. Level 3, or engineering options. Your default code is 3333. The functions that can be performed at access level 3 are all control options on level 2 and level 1, panel options, device options, network options, and PSU options. So within level 3, the first option to pop up is the panel menu. Here you can use the learn function to learn internal cards, loop devices, and network panels. You have the tone options for setting the tones for alarms, zones, zonal operations, evacuates, delays, and alerts and class chains. So you can have a different tone for each different type of alarm. Zone options. Within the zone settings, you can change the zone names and the dependency modes associated with those zones. There's an options, which allows you to set zone resound, the FARE and FWRE settings for your fire relay and fault relay if you want to change those, and delay times. A default option to set the panel back to default settings, and passwords, where you can set your new passwords. The next option is the device menu. Within the devices themselves, you can change the device name, the device's zone number. Will it operate the relay trigger, yes or no? Is it silenceable, yes or no? Is it going to be latched, yes or no? And does it operate in the dependency modes, yes or no? The next option is for sounders, and this is referring to the onboard sounders and how you want those to operate. There's typically the two sounder circuits on the PSU card. So you can choose whether the sounders will go for a general alarm. If someone hits the evacuate button, would you want them to sound during the delay? Do you want them to sound if a class change is active? And are they going to be silenceable, yes or no? In other words, do you want them to run until reset? Same for relays as well. This is referring to the onboard relays. Do you want the relays to operate in alarm, in evacuate, in fault? Do you want them to be fail-safe, i.e. inverted, yes or no? And are the relays going to be silenceable, yes or no? The next level 3 option is the networking menu. Within here, you can choose whether your whether your panel has local control. In other words, does it accept? Is it able to send controls out to the other panels, or does it control itself only when you silence and reset? And that's a yes or no option. Local mute control. Do you want your panel to be able to mute itself or the whole network? Yes or no. Local events. Again, do you want your panel to keep its events local or to display them on everyone else's panel? Again, yes or no. Local zones, yes or no? Do you want your panel to keep its zones locally or allow its zones to be spread across the network? Yes or no? Network mode. Is your network mode going to be fault tolerant, which is your default setting, i.e. a ring or a loop wiring for your network card? Or are you going to wire it in legacy mode or radial mode where it's just a 2-core from one panel to the other, to the other, to the other? Local general disablements. Do you want to allow your disablements to be local or to be network wide? Yes or no? And again, local class change and pulse. Do you want if someone operates the class change on your panel, is it to class change your local panel or to go network wide? Yes or no? Then we have the PSU menu. We have battery monitoring, yes or no. This allows you to turn the battery monitoring off for extreme circumstances. Obviously, these by default will be on. Again, the high Z monitoring, which is the high resistive fault for your batteries, do you want to turn that on or off? Again, it should be on as per standard. Charge during an alarm. If you want to save power and make your batteries last longer, you can turn off the charge during alarm. Again, yes or no options. Earth fault monitoring, yes or no, that should be left on. It can be a problem if you've got a loop with 2 loops with an earth fault on it. That can cause corruption data. So by default, your earth fault monitoring should be on, but you can turn it off temporarily. UPS mode, do you want to run the panel from some other type of 24 volt supply, such as a boat or some other usage? Again, this will turn off the internal monitoring and allow you to feed in 24 volts from another power supply. And low charge current, yes or no? Device information. A diagram of the loop wiring. It's a class A type installation with isolators. So literally from our loop out or A terminals, you're going around with a 2-core, picking up every device all the way around the building and back into the loop B or loop in terminals on the panel there. Short circuit isolators should be fitted at strategic points. Generally, normally it's just in or out for it's over 20 devices for your isolators, or every time you break into a new zone or zone boundary area. Earth faults is a little diagram just explaining earth faults, whether the positive or the negative is touching the screen or the building earth. Again, it won't damage the panel, but any earth faults on one loop is not normally too much of a problem. But if you have 2 loops of earth faults, literally your data from one loop will travel down through the earth into the cables of another loop 3 for instance, and loop 1, and there you'll be transposing information from loop 1 into loop 3, and that can cause bad data responses and corruption. So earth faults are a no-no for addressable systems. And that's the end of this video.